Cool. So yeah, so today I'd like to talk a little bit about introducing security into your data apps. So one of these things that we've kind of seen over the last several years is an evolution of the types of data products that people are producing. So back in the day, these used to be super static. These were, PDFs, slide decks, things like that. Kind of moving through sort of traditional BI, much more interactive, but still pretty on the rails in terms of the types of things that you can actually build. But more and more, and Hex is part of this trend, we're seeing people build out sort of fully featured code-based production grade full-on data applications as the product of their data work and their data teams. And these are really, really powerful, and they can do a lot of things. But as we all know, with great power comes great responsibility. And the fact that we can do a lot of things means that there are new implications for things that we have to consider. And one of the biggest ones here, as Gleb was mentioning earlier, is security. Your company hired a bunch of data analysts, hired you because they care a lot about their data, and they're trusting you to protect it. And it's easy to think about data security as being, trying to defend against this guy, some shadowy hacker on the dark web who's trying to come get your data. But the reality is, it's actually much more mundane set of problems. We've been talking a lot about, data quality, and that's, data quality, data corruption, data loss. Those are all security issues as well. Sometimes even security issues are as simple as you built an app that allows your users to accidentally run a giant query, your server runs out of memory, and all of a sudden the server is down for everybody else. And then, classically, sort of a data security issue of allowing to see people to see data that they don't have, that they shouldn't have access to. And if you have any kind of sensitive data, PII, PHI, this is something that you need to be paying a lot of attention to. And there are a lot of new ways that this stuff can go wrong when you start to move into a world of sort of these like fully fledged data apps. Now, security and application security is a huge topic, way, way too big for a 7-minute lightning talk. So I wanted to spend the rest of the time really digging in on one very common avenue that people often have security issues with their data apps. For the software engineers in the audience, this is probably something pretty familiar. But if you're new to building web applications and you're new to building applications in general, this is just something that's really important to kind of have a good understanding of. And that's SQL injection. So SQL injection is a pretty fun technique here. Let's say that we have a really simple data app where we're allowing people to retrieve facts about their favorite animals. We give them a nice little text box, and they can type in whatever their favorite animal is. And then in our Python, we turn this into a SQL query just with a really simple templated string. We take the animal that the user input and just shove it into our string like this. So this is great. This works perfectly well if the user types in a real animal like platypus or iguana or whatever. But what if the user types in the following: duck, semicolon, drop table, facts? Well, when you put this in the string, all of a sudden you end up with not one, but 2 SQL statements. Select star from facts where animal equals duck, and then drop table facts. Now, most SQL engines will very happily execute both statements. So after retrieving a bunch of facts about ducks, you will delete your entire facts database. I hope you're backing up your databases. It's another security topic for another time. This example is maybe a little bit contrived. There's other ways of getting around this by making sure that you're locking down your database users and things like that. But the ability to execute for an end user of an app to execute arbitrary SQL against your database is something that we want to avoid entirely, because they can do a lot of really malicious things with that. There's a lot of options, fortunately, for dealing with this. Most of them are pretty simple. One is just don't allow users to type in arbitrary things. In this case, it would be really simple to just change this text field into a dropdown. We could even populate it with all of the animals that are in our database, which is maybe even a better user experience because they'll know exactly what the options are. One fun fact about Hex, we actually have a lot of these different input widgets, check boxes, buttons, drop downs, whatever. And the drop down is actually by far and away the most popular input option here. So you can get a lot of mileage just out of doing this. And in this case, completely safe. You have complete control over what the strings are that are getting input into your query. Sometimes that's not possible. You can't maybe you can't enumerate all of the possible things that you think a user might input. But fortunately, SQL injection has been around for a long time. So most databases have a built-in construct called a prepared statement. And this allows you to separate out the actual query and the query structure from the values that are actually being inserted, and the database will handle those separately. So they'll treat the values just as harmless strings, and they'll actually run the SQL. So you don't actually end up with SQL that's contained in the value getting executed. Most SQL libraries, have this functionality. Sometimes it's called something a little different. You have to do a little digging to figure out what it is. But this is just a quick example here in pretty common Postgres library, where you pass in the templated string, and then you can also pass in a dictionary of values to go with that. And then lastly, sometimes both of those things don't work. So prepared statements, they actually only work for the value part of the query. You can't actually swap out things like identifiers. So it is a very last resort. You can check user input against a very narrow set of constraints. For example, if you're expecting a column, you can check that it actually is a column in the database. If you're expecting a keyword, you can check that it's one of a very small set of keywords that are valid for this. It's also worth noting that the inverse of this, so this is called Allowlisting or Whitelisting. The inverse of this, blocklisting, is actually not safe. If you try to just disallow a couple characters that you think are unsafe, it's actually very tricky to do that correctly. But anyway, you have a lot of options when you're going and building data apps, but one general best practice when you're dealing with security is a lot of the stuff can be pretty complicated. So you should never build it yourself if you don't have to. And you should look for tools that support this kind of thing out of the box. I've already talked a little bit about libraries and library support, but really the best possible thing you can do is look at your data tools and look at the tools that you're using to build these data products, whether it's like BI dashboards, apps, whatever, and look for ones that have security baked in as a first-class principle. So Hex, obviously, we care about this a lot. We've built it in. Retool and Looker are also good ones where I know that they've thought really carefully about their security. And this is actually something that I'm just generally really interested in. So if you know of good examples, I'd love to hear about them. But anyway, that's all I really have for today. I hope you learned something a little bit useful and practical about SQL injection. And feel free to hit me up if you have any questions later. So thanks.